Welcome to Pod 4 Journal Club. Today we are diving into something that sounds like science fiction, an AI that actually builds other AIs. We're looking at a paper that could totally change how we innovate, not just in AI, but maybe across all of science.
So here's our game plan. First, we're going to talk about the big problem holding AI research back. Then, we'll introduce the brand new AI scientists they built to fix it. We'll look at the pretty incredible results from its first test runs, peek under the hood to see how it works, and finally, dream a little about what this all means for the future of discovery.
All right, let's get right to the heart of it. With all this amazing progress we're seeing in AI, there's this one fundamental thing that's slowing everything down.
And that leads to this huge, ambitious question that this whole paper is trying to answer. It's not just about making AI a little bit better. It's about changing the speed we can do it at. Can we get AI to help us build the next generation of AI, but faster?
Okay, so let's break this down. Right now, progress in AI is basically limited by, well, us, humans. You know, research takes a ton of time, endless hours of coding and testing by hand, and a lot of the time it comes down to a scientist's gut feeling or intuition. This whole thing is called the human bottleneck, and it's a real drag on progress. So to try and shatter this bottleneck, the research team came up with a wild idea. What if they could build an entirely new kind of AI scientist? One that could automate all that hard, slow, manual work that humans have to do.
And here it is, meet ASI-Evolve. It comes from the brilliant folks at the GARE Group and the Shanghai AI Laboratory. You can think of it as an autonomous AI researcher, a system designed to actually conduct science all by itself.
It basically works in this non-stop four-step loop that's just like the scientific method. First, it learns from what we already know. Then, it comes up with a new idea, or a hypothesis. It runs an experiment to test that idea. And then, this is the really important part, it analyzes the results to figure out what it learned for the next go-around. And it just does this over and over and over, but at machine speed.
Now, what makes this thing tick? Well, it's got a couple of superpowers. The first one is what they call its cognition base. Just think of it like an entire scientific library that's been fed directly into the AI's brain. It's built from hundreds of real research papers, which gives the system a massive head start, so it isn't just randomly guessing in the dark. Its second superpower is the analyzer. This part is kind of like a wise mentor. It takes all the messy, complicated data from an experiment, not just a simple thumbs up or thumbs down, and it figures out the why. It turns that data into clear, useful insights that help the AI get smarter for the next experiment. It's actually learning.
Okay, so the theory sounds great, right? But did it actually work? Well, the researchers put ASI-Evo through some seriously tough trials to see if it could make real, meaningful discoveries on its own.
They tasked it with improving the three absolute pillars of any AI system. You've got the architecture, which is kind of like its brain, the data it learns from. Think of those as its textbooks. And the algorithms that guide its learning. That's its method. You need all three to make AI work. First up, could it design a fundamentally better AI brain? We're talking about creating totally new neural network architectures that are just plain better than the ones designed by human experts.
And the results? Honestly, they're pretty mind-blowing. After running thousands of automated experiments, it discovered 105 new state-of-the-art architectures. I mean, these things actually beat the highly optimized designs that humans had come up with.
So for the next test, they asked, could it create better textbooks for other AIs? This really means improving the quality of the training data, a process that's usually super tedious for humans, called data curation.
And you know what? It crushed it. The method it came up with for cleaning data boosted a large language model's performance by over 18 points on a really important knowledge test. That's not just a little improvement, that is a massive leap.
And for the grand finale, the last trial, could ASI-Evolve discover entirely new ways for an AI to learn? This means designing new learning algorithms completely from scratch.
The algorithm it designed was a genuine breakthrough. On a really complex math problem, it outperformed the best human-designed algorithm by up to 12.5 points. This is a big deal. It didn't just tweak something that already existed. It invented a better way to learn.
So these results are obviously super impressive. But as good scientists, the researchers wanted to know why. What was really making the system so effective? So they ran some tests to figure that out.
Now, this chart might look a little technical, but it tells a really cool story. It's from something called an ablation study, which is just a fancy way of saying they took the system apart piece by piece to see what happened. That red line shows the full system, learning super fast. But look what happens when they take away the analyzer, or the cognition base, the mentor, or the library. Progress just slows way down.
And this is where it all comes together and shows its real-world power. The team took one of the brain architectures designed by ASI-Evolve and applied it to a huge problem in medicine, predicting how drugs will interact with proteins in the body. The AI design model was way better, especially for what's called the cold start problem, predicting what will happen with brand new drugs and proteins. That's a massive challenge in drug discovery.
So when you take a step back and look at all of this, it's not just about one cool experiment. It really points to a fundamental shift in how science itself might get done in the, very near future.
The authors of the paper put it perfectly. They suggest we might be entering a new era. Instead of human scientists spending all our time grinding away trying to find solutions, we can focus our creativity on being the definers of problems, on asking the biggest, most important questions, and then letting our new AI colleagues explore the vast space of possible answers.
This research is so exciting because it really does open the door to incredible possibilities, moving us from thinking of AI as just a tool to seeing it as a true research partner. And it leaves us with this huge, thought-provoking question. Now that we might have an AI that can speed up science itself, what grand challenge should we ask it to solve next?